Everyone, hope everyone is doing well. Welcome to lecture number 6 of IoT. So in the last lecture we talked about the components or the perception layer, the devices that we use to build an embedded IoT device. Before going into the lesson in hand, we will just go through what we have learned so far and have a small recap on what we have learned. So the first things first, we took an introduction to IoT. Internet of Things describes a network of physical objects or things. In this case, they are embedded sensors, processing ability, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. So this is the basic definition of IoT, right? So till now we have talked about each IoT devices in this definition. The things in Internet of Things, we talked about cameras, lights, temperature monitoring, motion sensors, right? We gave more examples from smoke detectors, robo arms, to smart hospital beds, smart locks, autonomous driving vehicles, health monitoring tools, to weather monitoring tools. Then we looked at applications of these devices, how these devices communicate to each other for different purposes, right? We looked at a linear example of weather monitoring IoT tools, informing temperature control IoT devices in homes, buildings, and so on and so forth, and how that works. That was a linear example. Then we looked at a single situation, that was a fire extinguishing system, and how multiple IoT devices communicate through network to handle one scenario. Then we looked at a set of IoT devices which is there to weather monitoring for one purpose, can help different sectors, different domains, and so on and so forth. So by with all these examples, and we did a mix and match of examples as well. So from all this, we try to understand how IoT devices can be applied in the real world. What is IoT device, what are the properties, and what it can do, right? Then we talked about the basic architecture, right? We talked the basic architecture includes 4 layers: the perception layer, or the devices, or the physical layer, or we can say it's the hardware portion of this when coming into a IoT system. The network layer, where all these devices are connected together, right? How connected together and to the internet itself through networking, right? When components are connected to the internet today, cloud platforms come into play, and the application layer also come into play. But in this lesson, as we talked about, we are mainly concerned about the perception layer and a little bit about network layer, how to build a embedded system or a embedded device, embedded IoT device. So our movement should be towards that, how to build a IoT embedded device. But first, what we did was we identified what are IoT devices, how they work, and how they work in different domains, right? Then we went into basic components. In these basic components, we talk about sensors, actuators, embedded systems, and network devices. So when we talked about 2 layers above, in the device or sensor or perception or physical layer, whatever the word you can use, the first layer is about the physical component of it. Or in Internet of Things, it is the thing, it is the hardware device. So in that hardware device we can find three types of components. One is sensors, the other one is actuators, the next one is embedded systems. All these three hardware devices will be networked between each other, plus that small system or the embedded IoT component which was built by networking all these three would be then networked with other devices or to the internet directly to share data, right? That's when the network device section of it comes. So again, in Internet of Things, this would be the structure: multiple devices connected between each other, connected to IoT gateways, connected, then they are connected through standard protocols to the network. When from network it will go to cloud, it will become a cloud device, or you can say we can use cloud resources to calculate the data it's collected, and so on and so forth. And the application layer is there for interaction between for the humans to interact between these IoT devices and to understand what has these IoT devices collected as a set of data, and so on and so forth. In the cloud layer, of course, the processing takes place, right? So from that point we then started to talk about the sensors, actuators, network, and embedded systems, the four components to build a IoT device, right? So, right, to build a IoT device, right, we first need the architect. To build a IoT system, we need all these four layers. But to build a IoT device, we only need these two layers mainly. To build a singular IoT device or an embedded IoT device, we need these two layers, and in these two layers we can find these four components, right? Three of the components, sensors, actuators, and embedded systems, those are physical components, and that is we can see them in the physical layer or the perception layer. Then we have the network component, where we can use to connect these sensors actuated with the embedded system, plus the whole embedded system to the whole networked embedded system to the internet, right? So what in this chapter, we in the next set of lectures, then we try to understand what are the sensors. We talked about what kind of sensors are there in the market, what kind of sensors available in the market for us to obtain, right? While talking about sensors, we talked about, for the same purpose, there are different kinds of sensors with different parameters, different properties, so on and so forth. Which means when we have a problem to solve through IoT, we have to do our research. We talked about a data sheet for each of these sensors or each of these components, hardware devices. We have to go through that data sheet. We have to see the parameters. We have to select the correct one. Not only that, when we are selecting, we have to select one which is compatible with our embedded system as well, compatible with our code our code, or the code we are using, which is comfortable to us. We have to check the compatibility of all these components before getting them and trying to prototype a device, right? And these differences in properties, these differences in parameters when coming into sensing things, the physical size of it, the limitations of it, so on and so forth, not only applies to a single sensor topic, it applies to all sensors, right? We only went through one example, but it all applies to all these pressure, motion, proximity sensors, light sensors, so on and so forth. We talked about gas, sound, accelerometers, magnetometers. We talked about moisture, image, infrared, which the infrared sensor is also can be used for proximity sensors. We talked about gyroscopes, so on and so forth. We talked about the types of sensors. So when we as a IoT engineer, if you become IoT engineer, your requirement is to know what is the problem, and when you give a solution for that, you should know what are the sensors that is needed to be selected. Let's say if you are going to build a drone, right? The DJI drones and so on and so forth. You will once you look at it, you know that there is a image sensor there. So we need there is a camera. That means we need a image sensor. We know that we need to know whether it is right way up or not. Then we have a gyroscope. There should be a accelerometer, so on and so forth. We should understand what are the sensors that is needed for each and every problem that we are going to solve through IoT. Then we have from perception layer, right? We've first talked about sensors, then we went to talk about actuators, right? We talked about motors, solenoid valves, relays. Then we talked about similar to our sensors. Actuators also have its parameters, differences, the power, the ability of it, the power it uses. So depending on the scenario, we should be able to select the correct actuator. Then we talked about servo motors, we talked about LEDs, speakers, displays, so on and so forth. We talked about pumps, actuators for locks, actuators for curtains, and so on and so forth. So all end of the day, all are some different aspects of motors. If you take a pump, it's also a motor, but in a different configuration, so on and so forth. But again, when you check what is needed, right, when you see the problem, and when you see, oh, I want to build an IoT device, to maybe a medical IoT device to pump blood to a human being, or a sensitive thing like that, and when you are looking to pump water into a 50-story building, the actuator we are going to use will have very, very, very different parameters. So understanding the problem and understanding the parameters is up to the engineer, right? Then from that point onwards, we talked about networks, right? This is of course a separate topic. We talked about physical layer, data link layer, network layer, transport layer, application layer. Most of these protocols are there when we are talking about networking beyond IoT, right? So IoT is a part. If IoT means a device becoming a part of the internet, most of the protocols that are being used in communicating, if you are to communicate with the cloud, or if you are to communicate through the internet itself, send data through the internet itself, then it will be the normal internet standard protocols which are being used to communicate these things. So when you have the 7 layers of communication, right, the physical starting from the physical layer to the application layer, when the embedded IoT device communicates to the internet, it's going to be the same protocols. What we are going to learn today is when in the physical layer itself, right, when each device is going to talk to each device through their own network, right? Let's say we have a 50-story building, and in that 50-story building there will be smoke detectors, there will be door sensors to check all the doors are closed or not, things like that. There will be different kinds of other sensors, maybe lights, smart lights, lights that works from sound, so on and so forth. But all these have to be networked, and to build that network, rather than using the bandwidth of Wi-Fi or the normal networking system, we can use protocols and systems that are directly used to facilitate IoT devices, right? In that case, we can talk about Zigbee, we can talk about Z-Wave, right, and the others. Wi-Fi and Bluetooth, these things are commonly used. They consume a little bit more electricity, but they have a bigger capacity. But most of the time, when coming into IoT protocols, low electricity consumption plus networking ability is the importance, because the amount of data from one device transferred from one device would be very small. Except again, if you have something like image processing, then the amount of devices would be a lot. Then we talked about embedded systems. We talked about embedded systems, and we talked about how to select the relevant embedded system. We talked about Arduino a little bit more, right? We talked about how Arduino is connected, right, how the connections can be made. We talked about the data sheet of Arduino. We talked about the coding a little bit, not a lot. We just brushed through what is what, and right, this is the when you are connected to the internet, you can type your code and upload it. We will learn how to do that in the future. Right now we just to brush through it to understand what is it and what it's doing. So again, depending on the parameters, depending on the physical size, depending on the depending on the amount of processing power, we also have to select our embedded system. And we talked about Raspberry Pi. These Arduino and Raspberry Pi are the leading when coming into embedded systems, but we talked about a set of other examples as well. We talked about you can see here humidity and temperature sensor here fixed to Raspberry Pi, and how that works, right? We will learn how different systems works. But right now, right, you can see now the data which is being produced by this sensor is fed into the embedded system. The embedded system would have the ability to project that data, process that data if necessary, to process and maybe run commands. Like for example, another fan would be connected to this Raspberry Pi embedded system. So depending on if the temperature goes high, the fan speed will also increase. If the temperature goes low, the fan speed will lower down. To do such a thing, this has the ability and the processing power, right? So that would be a part of edge computing. That means that the whole IoT embedded system would or the embedded device, rather than system, the embedded device would be there. The requirement to connect to the internet and give that data to the internet, process it and take it back is not needed, because through the embedded system, that small set of codes or a small set of processors can be carried out, right? So it would be a part of edge computing. Um, so we talked about different features and so on and so forth. We talked about some other examples similar to them. Then our main goal is to build a embedded device, actually, not only embedded system but a embedded device. So we talk embedded device, a prototyping of an embedded device looks like these examples. You can see that this has a curtain, a relay. This is a curtain motor we talked about earlier, right, to move the curtains automatically up and down, or we can apply this motor because of its heavy duty nature to other applications as well, either lifting things and so on and so forth. So this, you can see that it's a fully remotely operated one. It's a full device and it's a prototype. So when you look at this, you won't see the examples that we see here, right? These are very nice devices. These look nice. It's aesthetically pleasing to the eye. So what is the difference? This is a prototype. Inside these devices, it looks like this, right? When prototyping, or when you are going to build your example, your IoT device, it's going to be something like in this picture, not like this. After you have a functioning prototype or the initial IoT device similar to this one or one of these circuits, or this one, you can see, right? Then you can build a housing or a cover to facilitate it that looks nice, maybe through 3D printing and so on and so forth. So you can put it into the market, right? After that, if necessary, large scale production would be then producing your own circuit devices, like old circuit models and so on and so forth, not prototyping embedded systems like Raspberry Pi and Arduino, but that is way into the future. So our goal through this these lessons is to understanding what is an IoT device, what does it do, what can it, how can we produce or prototype a IoT device. So up to this point, now I think you understand. We started from IoT device, right? Applications of IoT devices, right? Then we went on to see what's inside IoT device, right? The physical device, actuators, sensors, right? Embedded systems and other networking tools if necessary, right? We talked about like what are the components of these the components of a IoT device. Now in today's lesson we will be looking at the examples we looked earlier. That means these examples, IoT devices, right? These IoT devices, and try to recognize the sensors, actuators, and sensors, actuators, which the embedded system, the processing power is available for each and every device. So what we will try to do here is try to understand the sensors and the actuators in each IoT device and try to understand what is the purpose, what does it do, right? So from that you will then understand what are the sensors, what are the actuators need to build other IoT devices. So we are now, because we learned the components, let's see how these components apply, or let's see how what are the components available inside each and every example we looked at in the very first chapter, right? In the very first chapter we looked at these devices. Let's see what are the what are the hardware devices, sensors or actuators available in the perception layer of these each and every devices. What's inside, what are the sensors that are inside here. So that is our goal in this lesson. In this chapter we will first look at the IoT embedded devices in IoT systems, right? So we are going to, again, as I described, we are going to look at what is inside it, an introduction to IoT system development, right? So you may have remember we have seen all these examples, right? And what we are trying to see here is the IoT device, its application, and what are the sensors or actuators which is used for to make that particular device. So one of the main points that should be highlighted, and each and every device has a processing unit, has a network managing unit, has a power supply. So that is common for each and every IoT device. Each and every IoT device has a network component to it, has a processing component to it, and has a power supply. So we will be not talking about those particular parts which is shared common among all these examples. We will be looking at mainly the sensors and the actuators, right? So the embedded system or a processing device, a processing unit, the power supply, and power management, plus the networking either through cabling, Wi-Fi or Bluetooth or any other system, it will be there. So we are not going to look at this. We are mainly going to look at what are the sensors and actuators which is connected together or networked together with the embedded system which has the processing power to function these IoT devices. So combining everything together will make a IoT embedded device, right? So the first and foremost, the first example we took is the camera. So when we talked about the cameras, we talked about security cameras, we talked about cameras which are there to monitor your pets when you go outside, or to monitor your baby in another room, things like that. So different cameras comes with different architectures or different properties. So in the common use of cameras is for surveillance. This we have seen, and we know the properties of surveillance cameras. So when we talk about cameras, the main point, right, the main point would be the use of a image sensor. Every camera would have a image sensor, right? So this is the primary sensor that we would have. But then again, we know that different cameras may need different requirements. For example, if there's a camera system which is there to find image processing, that means it should have a HD camera. If the camera is there to let's say to monitor the night vision, so it should be a IR censored camera with IR lights, infrared lights, to be in use. right? So different kinds of there are different kinds of properties depending on the requirement. So but that again we talked about it depending on the requirement, but the common category is there will be a image sensor in each camera. Then we have proximity sensors and motion sensors. Proximity sensors and motion sensors, I put these two examples here mainly because there are cameras that switch on or highlights the image which has movement in it, right? If somebody goes nearby, if somebody goes nearby, or if there's some motion taking place in that picture frame, the camera will switch on, right? This is done to maybe preserve uh, data, to remove unnecessary data, or um, just to monitor when it is only necessary. In that particular moment the camera can switch on. Or if you take a doorbell camera, right, when you press the doorbell the camera switches on, other times it will be switched off. So in those places, right, to detect motion there will be motion sensors and proximity sensors. Motion sensors and proximity sensors uh, can be used for the same application as well, and to detect anything, any movement or any changes in the environment. Then following that up we have motors. We know that cameras can be moved or changed. The position of the camera, the frame of the picture can be changed by the movement of the particular camera. When coming into movement, right, when coming into movement we would then need actuators for sensing somebody's presence and to take in the image data. We use sensors. And for the movement of the camera itself, if you take security cameras you will see that if you can manually move the camera if you want, or you can there will be devices which will detect motion and turn the camera towards it. So that means 365 degrees can be covered by a single camera, which will reduce the amount of resources needed to be used for surveillance. But this can be achieved by using actuators rather than manually changing the position of the camera itself. We can automate the process by using a motor. In this case a servo motor, which can be used to control the positioning of the camera. If you want, let's say if you want a requirement the camera to always turn around at a constant speed, maybe you can use a geared motor. Or if you want to turn the camera and stop at a particular location, you can use the servo motor. So depending on the requirement or depending on the features of that particular camera solution, depending on either you are going to surveil a large area, a room, or if you are going to use for directing movies even, these properties can be changed. Because not only for surveillance, like if you think when conducting movies there are cameras with rigs in it which have different properties which can be remotely controlled. If you take drones, you will find the same situation. The drone and the camera positioning of the camera in some drones work independently, right? You may have a gimbals which works on different motors to balance the and image stabilizing, so on and so forth. The requirements will be endless, so depending on the requirement we can use the actuator. These sensors and actuators will be connected to a processing device. If the camera is used for image processing itself, right? If let's say image processing means, of course, image processing takes place, but if you are going to separately analyze a video where there are humans walking about, or we want to highlight the human movement, or we are going to highlight any movement that takes place, like if you have set up in a road, if there are vehicles going around, if the camera wants to focus on each vehicle, right? For things like that, there should be the processing power of it. So the processing power may comes in two scenarios. Number one, the processing power itself would be in the IoT system itself. Let's say if you have a security camera system inside a house or a building, all those images you don't need to send it to the cloud, right? And because it's a large amount of data, right? Send it to the cloud and uh, to analyze it for movement or anything which is taking illegal, if to see if illegal things are happening. So what can be done is the whole system can be networked and it could be used as an internal IoT device. The processing power could be centralized into a security room, right? The computers there can process those images and highlight any movement which is happening in each image, right? Then again, that is so cloud computing itself is not necessary. But let's say if there are things that you need to highlight or save for later, or you need more analyzation, enhancement, or things like that, which needs more computing power, then you can upload that particular data into the cloud. That's so, or if someone else needs access to that data, right? uh, let's say if you want to give it to the authorities, for the police or somebody to check, then you can either again connect it to the cloud or the internet. Through the internet you can give. And also we know when coming into baby monitoring, or if you take to monitor pets, or even your house security system, you can access those images through your internet, through your application. So it will become a part of Internet of Things. When coming into networking, the use of Zigbee or Z-Wave or things that are dedicated to IoT systems can most of the time cannot be used in camera systems, because the amount of data which has been transferred is large, especially when you have HD images. But normal protocols for internet, Wi-Fi can be used, or Ethernet connections can be used for such applications. Now combining all these, you will have combining all these sensors and actuators together, you will have a camera prototype, right? Then after that you can use a 3D printer or something to build a nice cover to it with functioning cogwheels and everything for the movement, which is connected to the server, and you will have a proper camera. Again, the networking part and the processing part is also there. These networking and processing in sections are common for all these devices, right? So we are just going to talk about the sensors and the actuators. Then we can come to the next example, which is temperature monitoring and control. We talked about it. We talked about temperature monitoring and control. We talked about how temperature and monitoring systems can be connected to the internet to take data outside the environment, or if it is if the temperature control system is in a building or a house or in a theater, to check the temperatures outside. But then the data inside that particular room or particular building should be also collected. For that, the temperature monitoring and control system should have pressure sensors, humidity and temperature sensors, moisture sensors, things like that, to understand the situation, or to understand the environment around it, right? So if you have a humidity and temperature sensor, then moisture sensors are not needed, right? Main component of this would be the humidity and the temperature sensor, either separately or in this case together, to understand the temperature inside the room. So temperature outside the room, outside in the environment, would be taken through internet, and it will be adjusted and maintained by monitoring the temperature inside it through a humidity and temperature sensor, right? Then all those information not only needed to be given to either the heating system of the building or the air conditioning system of the building. That information, the room temperature, should be displayed for human consumption. That is when the actuator comes into play. The actuator comes in, so that means we need a screen to display that information. It could be some small screen like this, which uses black and white data a presentation, or you can use a high tech, even a touch screen, depending on the requirement. You may have a touch screen or a screen with a device with buttons to interact, to change temperature, so on and so forth. So then again, the power supply, the network connection, and the processing for these is common. The power supply, the networking, and the processing is common. So what we have to do is, we have to check what are the sensors that is needed for each and every situation. Um, as I'm going through this, the main one which is needed would be the humidity and the temperature sensors, separately and together. Pressure inside a room would be barely normal. Depending on extreme situations, maybe factory floors or things like that, you would need a pressure sensor to understand. Or maybe maybe if you are in a balcony area or something like that, half open half closed maybe, but the use of humidity and temperature sensors are the most important ones, because those two are the main things that are being monitored. uh, Pressure sensors could be used maybe in height differences, or to understand quick changes in the environment, uh, when maybe when it is windy, or the pressure inside a room would drop down, things like that. But mainly it would be the humidity and temperature sensor along with the display. But then again, I will highlight the power. Power means the electricity, the networking, and processing power is common to all devices. If you go to lights, it would be the same. If you go to lights, and what will so we know this, we have seen this in our environment, right? Motion sensors or proximity sensors are mainly there, right, to detect if somebody has come into the room or going nearby, so the light can turn on or the intensity of the light can increase. This is done as a security measure in mostly if you take lights which are on which are outside buildings. But even if you take inside buildings, lights which works from motion detectors can be used to preserve energy, right? If there's a building, only few people are going in and out from that building, the light should not stay on at every time. But switching on and off would be also a hassle, maybe because the room area would be large and the switches would be located somewhere far away. So having a proximity sensor or a motion sensor to detect if people are coming in or not, we can switch on and switch off the lights accordingly. Then of course, following these motion sensors and proximity sensors, there's going to be light sensors. This is one of the main things which is used in handling light in large scale, large quantities. We talked about how the data can be propagated through the internet from one location to adjust lighting in entire buildings to all entire cities. Because if you take the street lights, right, they will come on and off depending on the lighting condition, like the availability of the sun. So if it is very cloudy, rainy, the lights will turn on quickly, earlier than a sunny day, because the availability of sunlight is low. If you take winter countries, this system is a good way of preserving energy, as well as switching on the lights at correct times, because during winter and summer the times of available light, it differs drastically in especially in countries towards the North Pole. So even in Sri Lanka, you may have seen street lights work with light sensors, so we can automate the entire system accordingly. So that means smart lights would have a light sensor. When we are talking about proximity sensors, motion sensors, and even sound sensors, not each and every smart light would have a sensor, but a single sensor for a particular area is more than enough to switch on all the lights around. So again, the networking, the internal networking part, the embedded system, the embedded light management system, the IoT system would be needed for this. The light sensing data would be given. Let's say if we are to build a highway, and in that highway we need to put lights along, let's say 100, 200, maybe 300 kilometers. We don't need to have each and every light with a light sensor. We just need to have for maybe each 10 kilometers or 20, maybe even 100 kilometers, we only need to have one light sensor or two light sensors, just to have a redundancy, uh, to detect the amount of light in the atmosphere, to detect the amount of sunlight in the atmosphere, and when needed to switch on the lights. Or this data can be taken through the internet itself, from a meteorological department live coverage or something like that. So there are options, right? Not each and every light should have this, but we can have lots of lights programmed in a way to work with this sensing data. Sound sensors, again, like motion sensors and proximity sensors, can be used for power, to control power consumption, right? When you clap, the lights will turn on. We know this. It's a much better and a easier way for all users, and a very good way to save electricity. Then again, when you see all these systems, you will understand that not everything is connected to the internet itself, but all these sensors, the lights, the control of the power or the electricity to the lights, and the sensors are being controlled by a centralized system, and they are networked to each other. The electricity that is flowing to the light should communicate with the signals which are being produced by the light sensor itself. So that means there should be a processing unit. That processing unit will switch on and off the lights depending on the readings, data which is being given by the light sensor or the sound sensor, right? So these are, so as you can see that a IoT embedded device or an embedded system could work in a closed loop environment as well, closed network environment as well. Let's go to the next example. The next example is the motion sensor. So inside the motion sensor, of course, we will find the best sensor would be the motion sensor itself. You may have seen this dome shape in light sensors where motion detected lights are there, right? The same thing happens here. So any movement in the environment can be detected. So the same function can be done by proximity sensors as well. You can use magnetometers as well to detect motion. The contact sensors also use magnetometers for detecting motion. So different kind of sensors can be used in different scenarios for the same application. So this is something that is needed to be highlighted. What we can use different kinds of sensors to detect differences in the environment. From that we can calculate what we need. For example, the motion sensor is the ideal sensor for detecting motion, but proximity sensors itself would have the properties to detect that. Magnetometers can also do that by keeping another keep by detecting by actually detecting the intensity of the magnets. So when the distance becomes greater, the intensity of the magnetism will reduce, thus mean there's movement. Even getting closer, then by the changing of those numbers we can say that movement has taken place. Especially if you take contact sensors are made from magnetometers mainly. We can so one sensor has a one of these components has a magnet, the other one would have the magnetometer or the sensor to detect the intensity of the magnets. When they are really close by, right, we can define the parameters, and we can say, oh, the door is closed, fully closed, or the window is fully closed. If the intensity of the magnets are not available, or if it is low, then we can say the door is open or the window is open. The contact sensor not only applies to windows and doors, we can even the motion sensor, it does not apply to doors and windows and only for security purposes. We can use these to have different machineries and different we can have these for different machineries, heavy duty machineries, moving parts. If you take large ships, manufacturing plants with like we can say metal working, construction of cars, things like that, heavy duty cranes, things like that would we can use these sensors to see if the machines are working correctly. So from if you take the contact sensors again, we can use motion sensors to see if any movement has taken place, and if that's so, we can also determine if there is any motion or contact taken place or not. I also added another unique sensor, pressure sensor. Why did I do that? So for example, let's say your application, when you open a door or when you open a valve, or if you want to detect that if something is opened or not, right? So uh, between the valve or the door or the window, the pressure difference may occur when it is open. When it is closed, it would be one pressure. When it is open, maybe the wind or liquid or fluids will come through, and then you will be able to detect that from that pressure difference. You will be able to detect that some kind of movement has taken place. If motion sensors or contact sensors can use pressure sensors in that sort of a manner, when especially when coming into let's say large scale water supply systems and things like that. Even if you take windows and doors in office rooms and so on and so forth, same application can be done. We just need to be creative when writing our code and finding solutions. Both of them, motion sensors and contact sensors, would use actuators. The actuator would be sound. So they will have a speaker system to sound the alarm or a doorbell or a notification alarm, something like that. And of course, these units can be directly connected to the intranet or to the internet itself, where let's say if you take a security scenario, you can have notifications, alerts popping up on your smartphone or your control room of the particular building or particular unit, right, notifying that there is motion that has taken place. um, so so we can see how motion sensors, contact sensors are there. Again, even if you take smart vehicles, or if you take, or not even autonomous vehicles, but most of the vehicles that we have today have motion sensors, actually proximity sensors, to detect, when you are reversing, are you close to a vehicle or a object or not, to prevent collisions, things like that as well. Then we will go to the other example, smart plugs or wall sockets or so on and so forth. We talked about them, right? So one of the main things that would have in smart plugs would be a relay. it would have this would act mainly as actuator, right? So depending on sensors from other IoT devices, let's say the contact sensor detected the opening of the door, so the lights can come on, the plugs will switch on. So that means this the information will be forwarded to the relay to give out power. So things like that can work. I also have added humidity, temperature sensors as well as light sensors to this option. So let's say if you want to if you are going to make a legacy system or a house with old systems, old heating systems, old lighting systems into a smart home, one of the best alternatives that you can use as a IoT device, rather than replacing everything in the house with a new device, right? Especially if you take the heating system and so on, it will be expensive. So one of the main processes of making IoT is trying to make the legacy device into a smart device. That can be achieved by controlling the electricity to that particular legacy device. Let's say you have a smart electricity distributing system or smart plugs with humidity and temperature fixed to the air conditioning or the heating system of the building or the house. These things can then read the necessary information, the atmospheric temperature, and switch on and off the AC or the heating system accordingly. If you have lights, right, if you have legacy systems for lights, if you have legacy systems for lights where wall sockets or the normal line gives electricity, you can use smart switches or smart plugs with light sensors in it. You can build those, right? You can use a system like that to automatically detect the intensity of the light inside the room when it becomes dark, right, when it becomes afternoon and night. When the natural light falls down, the plugs will switch on, start giving out electricity, so not the lights would come on. So if you have if you have a legacy system, to make, we don't need to replace everything with a smart bulb or something like that. We can use things like smart sockets, smart light switches, and so on, with which we have relays, right? They will communicate with the processing units and the networking to see what is the temperature, or what is the light intensity of the room, and switching them on. So if you go to the next example, right, it would be the smart smoke detectors. We have extensively talked about how these could function, right? So smart smoke detectors would have definitely would have humidity and temperature sensors. Then it would have gas sensors, right, to detect what kind of atmospheric gases there are, and to understand whether the gases are poisonous, or is it gases that are normally emits from fire situations or electricity fires, things like that, right? By detecting those chemicals and by detecting the temperature of the room, change in humidity, and so on and so forth, by using these sensors, we will be able to understand, or the smart smoke detector could then calculate whether there's a fire or not. So when you have a smart smoke detector or a set of smart smoke detectors, there should be power source given to those smart smoke detectors. So there will be, for actuator side, there will be relays working towards it. And of course, all traditionally all smoke alarms would have speakers with them to turn on, and also smoke alarms would have LED bulbs as well, which I haven't put over here, but also another actuator that we can see is the LED bulb that would indicate that it has detected detected smoke, and the alarm would go off. So we need a speaker as well. So all these smoke alarms can be controlled, the electricity flow to these smoke alarms can be controlled through a relay. And of course, again, as I told before, all these IoT devices would have a processing unit, would have the power supply, and would have the networking as common features, right? On top of these sensors and actuators, the processing power, the power supply, and the networking would be given and mandatory when coming into IoT devices. Then we have the air purifier. Air purifier will also have the same kind of the same sensors, right? Humidity, temperature sensors, and gas sensors, which would detect the particles in the air and how much how much impurity or impurities are available in the air particles, and they can switch on and off accordingly, right? Can increase or decrease the intensity of air intake taken in to purify. Things like that can be adjusted. Of course, most of the air purifiers that are there on the market today can be connected to the internet and can be remotely controlled, and the data can be shared. Not only these there are these sensors, there are sensors to detect if the purification filters have dried up, or the purification or they needed to be replaced. I also have added a relay as a actuator because air purifiers conduct a lot of electricity as well. So if you have a normal processing system, we would need a relay system to function the entire air purification system. There will be a lot of electricity consumed. Then we have our control centers. If you take these control centers or control IoT devices, they are a primary part of IoT. The specifications or the function of a control center of IoT is a little bit different from IoT device itself. This is the point where the human interaction with the IoT system takes place. The control center itself could take the shape and form of a small touch panel for a smart screen in a tablet PC, or it would take the form of like voice control devices like Alexa, right, or the Google Nest or things like that. There will be, you can use your smartphone. There will be applications. If you have much more bigger applications which expands over bigger than a house or a smart house or a smart building, maybe if you want to have smart cities, we will basically use computers, control centers, places like that to collect and display all these IoT device data. So in that sense, so control centers, right? The examples that I have given here, shown here, are normally used in smart homes. But again, as I told you, smart or control centers for IoT devices comes in all shapes and form. Of course, if you have Alexa or Google Nest or things like that, of course the sound sensor or a mic would be there to listen to the commands, to listen to your voice and to understand and the commands, right? So of course, again, like everything else, they will be connected to the network. They will be having their own power supply. They will be having their own processing units. Some of the control centers would have cameras, right? So if you take the doorbell, for example, a smart doorbell would be directly connected to your control panel or your control display in your smart home, so you will see who's available there, or you can also switch on your camera and talk to them who's outside your door, right? And there will be, then if you have your smart doorbells and things like that, you will have your speakers, and of course, if you are interacting with voice, that means also you will have your speakers. Then of course you will have displays as well for interaction, to displaying information from, we talked about earlier as an example, we talked about our temperature gauges. If you of course have cameras, there will be a display unit as well for seeing the pictures, right? Things like that, showing information of how many smart plugs are switched on or switched off, how many lights are switched on and switched off inside the house. All the information, things like that, could be displayed in a screen. When I say screen, do not only limit the screens to the pictures here, right? It could be a mobile application, it could be your computer or laptop or tablet PC. Depending on your requirement, the screen would vary. So control centers are a main point of IoT devices that is needed to be considered. So let's put a small example here, right? If you are to ask from Alexa what is the weather is going to be like, right? So we would see an interaction between that device and devices which are connected to the internet from the meteorological department, right? They will take the data from the internet itself, but that particular set of data will be shared by IoT devices of the meteorological department, which would share the temperature, the humidity, or whether it's going to rain or is it raining, or things like that, the real time weather information, and it will be relayed to Alexa, and it will give an output in voice form. So that means that you can see how these IoT devices interact through the internet itself. Sometimes it's not clearly visible, because what we know is Alexa connects to the internet and takes the information, and we should know how that information is there in the first place. So from control centers, now we have talked about most of these examples which are here are more geared towards home consumption, right? And one of the main things that I wanted to highlight is, when you are making a IoT device, depending on the job role of that IoT device, depending on what that IoT device does, it would have maybe one or couple of sensors and actuators together. The IoT device itself would have processing power. it will become IoT device when the data that is being collected from the sensors are shared through networking to other locations, other devices, other people, through control centers and so on and so forth, right? But end of the day, when you say a IoT device, it would be a mixture of one or more sensors and one or more actuators connected together with processing power, with an embedded system. We talked about Raspberry, we talked about Arduino, right, which gives the processing power, right? So that means one of the points that is needed to be reminded here is that when we talk about edge computing, right, there will be, rather than giving all the data into the cloud itself, IoT devices possess the power to process information inside the IoT device itself, right? That's also, and only the needed information, only the required information will be shared through the internet to the respective parties. This example could not be seen maybe in household or smart house appliances, but if you take places like factories, smart cities, smart grids, places where a lot of IoT devices work in tandem to share data and have a real-time view of the environment, right? You will understand that there will be part of it or in edge computing, or the IoT device itself would compute the information and relay only the information which is needed to the end user. One of the examples, let's take this motion sensor. This motion sensor will keep on checking for any motion that is happening in the surrounding environment where it is monitoring. But that all the data which it collects, right, if it collects data every second or every millisecond, if it sees if there is motion or not, that data is not relayed to the end user. But when motion takes place, then the alarms will go off, then the sounds will happen, then maybe a notification will be sent through internet to the if it is a surveillance system, to the security group or the police station or things like that, or the owner of the house. Or if it is a factory and we are detecting the motion of some machinery, if unwanted motion takes place, alarm bells will go off in the control center, right? So most of the time, the processing of data, whether motion has taken place or not, would happen in this IoT device itself. Only when the information is needed, it can be relayed to the centralized system through the network, right? So depending on the processing power of the IoT device itself, sometimes we don't need cloud computing. We only input data to cloud computing when it is necessary. So that is one of the things that I wanted to tell you. And the other one is, of course, if you are to build an embedded IoT device, sometimes it would have only, if you small applications would have only one sensor or one actuator, but large scale applications would have couple of sensors and actuators working in tandem together to build this IoT device. For example, if you take a simple temperature and monitoring control system, right, you would basically need this sensor, humidity and temperature sensor. to detect the temperature inside the room, right? If you are going to make the very simplest one, that sensor is more than enough. Then you will have the actuator as the display. You will have a network, of course you will have a network component where you can take data from outside sources and compare the temperature inside and outside. Of course then it will be networked into either a air conditioning system or a heating system to activate them. So things like that. So if from that point onwards, let's go to the next set of examples, right? We have the robot arm. We talked about this. We talked about how these are used in industrial scenarios, especially when building or manufacturing vehicles. It's a very famous site today. If you check on YouTube any vehicle manufacturing plant, you will see robot arms working. But it is necessary to understand, mostly in heavy industry, when automating heavy industry, robot arms are used. But if this to become a IoT device, this should have the ability to understand or share data. First, obtain data around its surroundings, right? So if you have a manufacturing line, right, you will have motion sensors to see the movement of the arm, or proximity sensors to see how close the arm is to the manufacturing objects. You will have gyroscopes to understand the alignment or the alignment of the arm at any given point. I also added magnetometers, because if you take magnetometers, you can use magnetic tapes or small magnets as focus points. So using a magnetometer, that these arms can move into the position it needs. There will be image sensors. One of the things that a very complex example for this is that there are experiments going on whether remotely doctors could do operations. For that, they use cameras to get live feed of the operating table, where robo arms can be moved to carry out the operation. If it is a robo arm, right, that means it should have actuators. Definitely it should have actuators. Heavier the machinery, the more the power it needs to lift things, to weld, paint, move, so on and so forth. These robot arms are needed. So that means you will have definitely a relay to control the power. You will have servo motors, and you will have motors, right, moving the arm up and down, side to side, right? You will have the gyroscope to understand the positioning of the arm itself. You will have proximity sensors to see if the arm is moving safely around, and if there is anything near the arm's proximity, so on and so forth, right? The amount of sensors are endless, right? The amount of sensors that is being used in these things are endless. It is up to the engineer who's designing these arms to actually see the requirement and use the correct sensors. As we talked about, these robot arms are working, some work alone, most of the time they work in manufacturing lines in tandem with other robotic arms, which means each robot arm is networked to each other, and there is a centralized processing location right? We can say it's the cloud, it could be inside the factory itself, it could be intranet. Whatever it is, it would have central processing power for all, to carry out all the activities in tandem, right, in a proper fashion, right, one step after the other, right? So these robot arms should work in sync together. That would be done by a central processing unit. But again, these robot arms, if they have sensors, if they have motors, that means they will also possess processing power as well. The other part of when building a robotic arm or building any IoT device, what I told you is that the physical component, the claws and the movement of it, the cogwheels and so on and so forth, right, should be there as well, right? Because when we talk about IoT device, most of the time the IoT device itself is not most of the time, definitely the IoT device itself could be a hardware device, a physical device. Now if you take the examples above, you can see that these are if you have the sensors inside this container unit, right, you can 3D print these container units and you can build it. Like if you take something like a robotic arm, it's a little bit complicated part. You will be, if you are to do a project on this, you will be able to buy needed components on the internet without any problem. Actually, you can buy all these sensors, actuators and everything on the internet or in shops that cater these products, and you can build a project. But additionally, if you are going to build a IoT device, let's say a drone, right, or a robotic arm or so on and so forth, right, your initial prototyping model, after building the circuit part of it, right, you will be need to actually design the physical object. If you are going to prototype a robotic arm, you need a prototype of it. So the best thing to do would be to do a little bit of mechanical engineering, in that we have to take some help from mechanical engineers and build a 3D model of the arm itself. And after that we can 3D print each component, and or we can buy, if there is the components available in the market, we can buy it from there, or we can 3D print these each and every component, and we can build our robotic arm. As you can see, this is a very simple robotic arm which works with necessary small motors, and the necessary cogwheels are there. We can safely say the strength of it, this is not built for a very heavy to build, lift things up, very heavy things, or to do very to do activities which need a lot of strength. But as for a project, for a prototype, for a demonstration model, this would be more than enough. So that particular part of it also needed. If you are going to build a IoT project, right, you would need also a cover, or the husk, or the body of the IoT device build. In that particular case, I just gave you a small example for the robotic arm. You can 3D print it, which in this case the robotic arm would be a little bit extreme. So if you can basically 3D print all these devices, if you want to build the full functioning device. But when you are prototype as a IT engineer or as an electronic engineer, your main focus would be to program and network all these sensors and actuators together to make a functioning device. That's the second step would be when you are creating a product itself, to have a nice cover built and put everything in place in a nice eye pleasing fashion, right? So then we will go to the smart fridge as well. So of course, fridges works with pumps. We know that, compressed air, and to keep the cold inside. So we would need pressure sensors, we would need humidity and temperature sensors, gas sensors. Gas sensors would be there to see if something has gone wrong or gone bad inside the fridge itself. And then of course, we have sound and camera sensors in the fridge. So let's go one by one, and we will start from, I think the explanation is pretty much simple for pressure sensors, because there are pumps and everything working, right? Air compression and AC is working, so there would be a pressure sensor inside. Humidity and temperature sensor, of course, it's a fridge, the temperature inside should be monitored and controlled. Gas sensors, again, food can go bad or things can go wrong inside, so maybe knowing the contents of the air particles inside the fridge is a positive. In the smart fridge, of course, there are other components which are which are there. You can see that there is a large screen, so in actuator sense there would be a screen available. With the screen you will find sound, you will find mics. If you can command the smart fridge through voice recognition, you don't then there's also the option, you don't need to open the fridge to see what's inside. You will have you would have a camera to see what's inside the fridge, so energy wastage would be stopped. That can be also done by a image sensor. Another sensor that came into my mind while talking about the smart fridge would be the contact sensor itself, because the fridge, if the fridge door is opened or closed, right, it is very necessary to see if all the seals are properly attached. And you know that the binding nature of the fridge door, right, it's a small magnet. Some fridges have small magnets to fix the door, lock it in. So we can use magnetometers to see if the seal is there or not. And of course, we talked about how this fridge is connected to the internet, right? Use of the smart fridge would be, somebody who's using this fridge has gone to work, and when they are coming back home, they want to see if they need to bring groceries or not. They can quickly access the fridge camera through the internet from their smartphone, and they can check what are the things inside the fridge, and so what is there and what is not there, whether they need to buy or not, things like that. Then cooking recipes and things like that can be downloaded from the internet. We talked about these things earlier as well. And of course, this would have a lot of sensors. It would have relays. It would relays definitely built into the device. If the doors open by themselves, then it would have motors as well, of course. But as engineers, we can dream of such things and see if these are feasible. Again, the smart fridge itself is a combination of all these things. The power supply is there, the networking is definitely there, and the processing power is also there. That is one of the things that is needed to be highlighted again, right? We talked about embedded systems. Of course, if you're going to have a screen, you will have a GPU. If you're going to store information about your grocery list, your your cooking recipes, and so on and so forth, there will be a processor inside. If the fridge is to check the humidity or the temperature inside the fridge, or the pressure inside the valves of the fridge, and so on and so forth, and to maintain good temperature, high efficiency when coming into energy usage, right? So to do that, it would need the processing power to act by itself. So that point is also needed to be clarified. So that means the processing power, the electricity, the networking is definitely there inside the fridge, and we have to then connect all these with the sensors and the actuators. The next example, of course, the Roomba vacuum. So this is an automated vacuum system. It would, we talked about it, it would travel around the floor by itself, and when it reaches objects or barriers in front of them, they will turn and they will scan for a location which is possible for them to move, right? Where there is space, it will move around, right? So that means one of the main sensors it would have would be proximity sensors. It would be checking for barriers in front of them and how close they are to it, and it would be turning around to avoid them. Then there will be accelerometers to check the movement of accelerometers would be there to check the movement of the Roomba itself, because it can accelerate and it can decelerate, so to have keep eye on those things as well. For actuators, Roombas would have motors and servo motors for turning 360 degrees in one place, as well as traveling in back and forth as well. And of course, inside the Roomba there would be a vacuum. The vacuum would have a motor itself, and of course there are small sweeping gadgets as well. Those are also controlled by motors. Overall, there would be at least, safe to say, at least 5 motors would be there inside this Roomba vacuum to work. Again, the automated travel of this vacuum, the automated function of this vacuum is done by itself. There's no need to connect to the internet and send the data to a cloud source to process data. All the information will be processed inside for traveling around the room without getting stuck or without bumping into things, would be done by the processing power of the device itself. The information that is related to the internet would be the information that how long it is cleaned, is the battery on enough or low, or the cleaning process is completed, or the user can program the vacuum to clean at a given time where they are not available, so that the vacuum can automatically clean without disturbing anybody. So things like that, right? So again, the processing is also there, so that particular part is also covered inside the device itself. So we can see, even when coming into complex examples, from simple examples to complex example of a IoT device, the IoT device or IoT embedded system would contain multiple number of actuators and sensors with processing power and networking and a power source so all those components together makes a IoT device, right? So when we have a problem and we need to give a solution from IoT, we should be able to select our sensors and actuators correctly to do the function. Depending on the sensors, actuators, and of course the compatibility and the processing power of it, right, we can design, if we want to design other physical components, like if you take the robotic arm, if you take the fridge, you need to build the frame, those parts are physically needed to be built. When those every component is fused together, you will have a device which would connect to the internet and become a part of the internet itself. Our main concentration right now is to build a simple IoT device. We don't need to build the structure of these things. Mainly we are looking to build a IoT embedded device with the processing power, the sensors and the actuators mainly. Then we can go to networking. Before going into the last section of our examples, right, I wanted to now describe about or to explain about what is the difference between a IoT device and what is the networking inside IoT device and how the whole IoT system works, to just to give a picture on what are the components, what are the parts we are talking about in each and every chapter, right? So as we discussed, we went through, we took devices, we took applications and examples of IoT devices, then we are now we looked at our sensors, our actuators, our processing embedded systems which is used for processing. We looked at our networking, right? So right now we are looking at what are the sensors and actuators which are there in each IoT device, right? So in the next diagram, in this diagram, I want to explain what are the components or what are the sections we are talking about. So Internet of Things or IoT systems or the global IoT infrastructure would look like this, right? A collection of different IoT systems would be connected through the internet, exchanging data and using cloud resources. That is one end of the IoT systems. The other end of it would be our IoT devices, right? So each and every example we are talking about, the Roomba or the smart fridge or the control centers, air purifiers, smoke detectors, other sensors from plugs to everything, cameras to smart lights, everything that we talked about, end of everything would be a smart device, right? That is the main point, right? Like what we are learning here today is how to build a IoT device in the network of IoT. The simplest and the very first thing would be a IoT device, right? If you take this IoT device, it would have sensors, it would have actuators, right? A IoT device may only have one sensor and would be carrying out only one function, right? Let's go to our examples again and try to understand this scenario from this, right? If you take this, you can see that there in the weather monitoring station would be a IoT device, but there are different set of sensors in it for that device to work, right? So what we are seeing here is a similar scenario. If you take a Roomba vacuum, right, you will have sensors, accelerometers or proximity sensors. Then you have a set of actuators, servo motors or motors to move around, right? So we have one or more so it's a combination of actuators and sensors, or just actuators, or it could be just sensors, right? Each of these sensors and actuators is connected to our embedded system or the processing unit. Each of these sensors need to process its data. It will take in raw data that it will take in raw data of the environment. Each sensor, right? If it is an image sensor, it will take in images, right? Data of raw data of images. If it is a magnetometer, it will read the amount of magnetism that it can feel. Gyroscope will read it the inclination, right, according to XYZ axis. Proximity sensors would detect the difference between in the either ultrasonic sound bouncing of object and coming back to it, the time differences, and these things needed to be processed. They will give out raw data, and that particular raw data have to be processed. That processing does not need to be conducted in the cloud itself, because it may take a long time and it will create unnecessary traffic in the network itself. So here, if you know the concept of edge computing, right, it is the concept of edge computing is not not computing everything in the cloud itself. Whatever that can be computed in your PC itself or your machine or your processing unit itself would be processed there, and only the relevant data would be sent to cloud. This is to create efficiency, to stop unnecessary network utilization, so on and so forth, right? If you're going to play a multiplayer game, you would see edge computing, because not though you are connected to a server, right, not every part of especially your GPU processing will be done by your machine itself. It won't be done by the cloud system. So that particular GPU processes that is taken in your PC itself is called edge computing. So in here, the IoT device itself has the processing power, does not need to communicate with other processors, or does not need other cloud resources or other systems to process, right? Normally there will be processing power enough to carry out its own work or own way to have the data, have the needed data processed. It will have the processing power in itself. Then of course, with the processor would also then would have a connection between your network, IoT device network. Now here we talked about network systems, right? When we talked about networking, right, we talked about different networks. So Wi-Fi and Bluetooth, these are common things, but we talked about networks which are dedicated to IoT devices itself. We talked about Zigbee, we talked about Z-Wave, Sigfox, long range WAN connections, right? We talked about these as well. Especially these are mainly NB-IoT. These are low power connectivity systems, specially dedicated. Zigbee, Z-Wave, Sigfox, these are specially dedicatedly made for IoT networking itself, right? So we can use those networking apparatus to connect to other IoT devices, right? If you take a building which has multiple IoT devices, it could be hundreds, right? Each and every network device, so this is one network. Inside each and every IoT device, it would look like this, right? and each and every IoT device can support other IoT devices to make a network of its own, right? And that those devices can directly connect to the network itself. So this network of IoT devices working together. If you take a set of robotic arms, let's say we have 50 robotic arms in the manufacturing line, working together would create this IoT system. Smoke detectors, there would be hundreds and thousands of smoke detectors in a large scale building, a shopping mall, a complex, or something like that. Those things connected or networked together, right? Each device connected together through IoT networking would create a network system. And when those devices need to share its data beyond its own intranet, beyond its IoT system, right? Because like if you take a robotic arm, or if you take smoke detectors, right? You don't need to notify, or no, you don't need to share that data with the internet at all, because you can notify it to a central location position and do the processing. So it would be, the data will be processed and commands will be given inside the IoT system itself. But let's say the headquarters of, let's say, BMW or Audi or Volkswagen or Benz or Toyota, Nissan wants to see the efficiency data, or wants to see how long does a robotic arm works, is there any errors that occur, or need to share the logs or those data, or if the smoke detectors detect any heat signature or things like that, and they need to inform third parties like the fire brigade or the owners of the building through cellular network or notifications or things like that, then they have to reach outside its own system. When that happens, IoT devices can connect with a router that would support, or internet networking protocol. The device itself would support internet networking protocols. They can use Wi-Fi, right? They can use normal protocols, networking systems, right? Then it will, from physical layer to application layer, right, would follow the standardized protocols for internet itself, right, and communicate through the internet or cloud. If there is cloud processing to be done, if there is things like that to be done, it can be done on the cloud itself, and that data could be passed on to other IoT systems. Inside each IoT system, you will see a bunch of IoT devices, and in each IoT device, you will see a set of sensors, a set of actuators working together with the processing power. So when we talk about each device, we are only talking about this particular section. We are only talking about a IoT device, only this, which sensors, processing power, actuators, and networking capabilities. This would be a embedded IoT device. So what we are looking at in this lessons, right? In these lessons, what we are trying to understand is, right, this is the breakdown of a IoT device, right? That device would communicate to other IoT devices, right? And through then it would be connected to network of things, Internet of Things, through networking, where it has the IoT system would have the ability to connect it and use cloud resources or information or data from other IoT systems. So because we looked at examples of IoT systems before, right? Let's look at this. Now you can see, now this is a IoT. There are a set of IoT devices here, which creates a IoT system, right? It has the weather monitoring capabilities as well as those information for light, the intensity of the sunlight, right? So it would be a IoT system that one device would monitor the humidity, the other one would be temperature, there will be one for detecting light, there will be other one for detecting wind, and all these IoT devices would be taking in raw data and either processing inside the device, right? You will see now, for detecting wind, this small device would spin due to the wind, and that would register from the direction of the wind and the speed of the wind. So the raw data would be the number of RPMs that this device would take. So there should be coding and calculation to determine, or if it is having this much number of RPMs, that means the wind speed should be so and so. So those set of coding should be inside the IoT system itself. So when these, let's say the light intensity data is taken in, right? The light intensity data is used in other IoT devices or IoT systems. If you have a smart grid, if you have a smart city, that smart city would have street lights, right? That street lights will turn on when we look at when we have the readings of this IoT device, which can detect the intensity of the sunlight, right? So that means the weather station system, so there would be one device that would be, let's say, this device, right? So inside this device it will look like this. This device would detect the intensity of sunlight, right? And when that device detects the intensity of the sunlight itself, that data would be passed on through the networking system into the internet, and it would then reach out either directly or through cloud processing, depending on the system it used. But after this point it will be on the internet itself, so it will be communicating through the internet to the smart grid or the smart street light system of the smart city, and would be giving out data saying, okay, the intensity of the light would be less or more, or whatever the data which needs to turn on and off the lights. So that means the weather monitoring IoT system is now communicating with the street light IoT system of the city itself. So that's how the communication of this would work, right? Inside the IoT device, there will be sensors. There will be only sensors in this IoT device to detect the intensity of the sunlight itself. So to detect the intensity of the sunlight, there will be sensors inside this IoT device, and that IoT device will be communicating with that whole IoT system data will be sent to the cloud, and the necessary data will be obtained by another IoT system to turn on the lights in a building, in the streets, in a smart city, or in your house as well, right? Or there can be another system like this. The street lights itself could be isolated. So let's say this IoT device would have a sensor to detect the intensity of the sunlight, and other IoT devices would be street light systems. So when this IoT device, right, so it would be processing data when throughout the day, and when a certain threshold is reached, right, when a certain number is reached, right, it would then, according to that code, they have determined whether it is dark or not. When it becomes dark, it will send a signal or a command to all these IoT devices, which are the street lights, to switch their actuators or their bulbs on to light up the street. So in that scenario, the IoT network itself is more than enough. No need to go through systems to systems. So you can see that in IoT, right, when we say, oh, there's a cloud involved, there's processing involved, there's networking involved, right? In IoT, the networking and processing is involved in each and every step. In the IoT system itself, networking is involved. In the IoT device itself, networking is involved. When you take IoT, cloud computing is involved, talking through internet is involved, but again, same network scenario can be applicable in an IoT system itself. If you take a smart home, we can design a smart home to have the necessary processors just inside the smart home itself. If the smart home have the necessary sensors to determine the weather conditions and so on and so forth, the lighting system of the house does not need to rely on internet information to switch on the lights and or switch off the lights automatically. So if there is confusion for you to understand where IoT starts and where IoT ends, I think looking at this picture will provide you a good example of how IoT works, right? Our main goal is to build a IoT device, right? A prototype IoT device or a simple IoT device, right? And that IoT device may or may not be connected to the internet itself. But it would have the following properties. It would have sensor, at least one sensor. It would have actuator or at least one actuator. It would have processing power. It would have networking power, and each and every device would have electricity, right? Those are the main parts that you need to consider. A set of IoT devices network together, working together to fulfill one or more tasks would be a IoT system, and each IoT system connected to each other through the internet, right? If you take vast quantities of IoT, right, it could be in a manufacturing plant, right? Like if you take manufacturing plants, Toyota would have manufacturing plants around the world. So if they want to see each and every machine working properly or not, they can obtain that data through the internet to one location. But that does not mean that every data would be processed in a specific data center sent through the internet itself. Data processing can occur in the device itself. If you take smart cameras, right, you would have image processing algorithms in the cameras itself processing the particular image, right? If somebody wants to see that image remotely, then that image information would be passed through the internet, right? Would be passed through the internet to the particular person's smartphone or device, right? So this is the basic structure of a IoT system. And now you understand when we say IoT device, how they are connected together and how the networking will take place, right? So I think now the understanding of how these things work, how IoT device work, right? What are the sensors and how the sensors build a IoT device, sensors and actuators working together builds a IoT device. I think that understanding is there, right? I think we have reached close to 2 hours now, right? We will look at in the next lesson we will look at these other examples, and then we will look at IoT system creation, right? Before going into actually coding and building IoT device, we still have to cover the networking part as well, to understand the IoT networks, right? As I told you, inside the IoT system we don't need to use protocols that are being used in internet in your smartphones or your laptops to communicate through the internet itself. There are low power consuming protocols as Zigbee and so on, so we will just look at them as well before going into coding and everything. For now we will pause our lesson from here, and from the next lecture we will start the rest of the examples and we will carry out from there. So have a great day everyone.